plus.
No, let me put it up. See, why H plus is called proton. First, you understand that.
Yeah.
Why it is H plus is a proton.
Oh, man, the proton has the plus reaction, right? And then the
Why we, yes, proton has a positive charge. That is good.
yeah,
But why don't we call any other element a proton or neutron? Because hydrogen is the only one which has no neutrons, right? It
yeah,
has only a proton and an electron. And once that electron is lost,
yeah,
okay, the electron is lost, what will happen? You will it will have only the proton. So that's why the hydrogen ion is called as a proton. Okay.
okay,
So when we
okay.
call about here in acids and bases a proton, so it is synchronized, like it is synonymous to the hydrogen ion, not the subatomic particle. Okay.
Okay.
This thing. Okay. Clear this part. So that's why H plus is a proton. So here, according to Arrhenius theory, your acid will produce a proton, and your base will produce hydroxide ion in the aqueous solution. Now, aqueous solution means in the water, when they are mixed in the water. And always, acids and bases are aqueous solutions only, right? They are liquids. Okay.
Yeah.
Yeah. And according to Bronsted-Lowry theory, it is your acids are proton donors.
And it's
Okay. Proton donors, because they'll give off, right? Once they release H plus, proton donors. But here sometimes now like we have some examples also where always it is not the hydroxide ion. Now, for example, ammonia, right?
yeah,
You see ammonia. Now when this is put it in aqueous solution, right? This does not have hydroxide ion, no? So how will it release hydroxide ion? But what happens when it gets dissolved in water? Okay, so this will produce, it accepts a proton and then will be able to furnish OH minus. Okay, so that's why Arrhenius theory, he gave up about the acids, but Bronsted one was a evaluated one, because it included the exceptions also, where even though in the compound we don't have hydroxide ion, but still they are able to produce hydroxide ion in the what do you have in the solution. So how does that happen? So that's why the definition was changed. It became proton acceptor. Right now you can see, you understand now why it is called proton acceptor. So which is widely used. Okay.
So Bronsted-Lowry, it's acids. So base accepts protons and acids give protons, right?
Yes. So that is the thing. Okay. Getting it?
Yeah. Let me write this down.